folks, how we doing? Hopefully got worksheet 3.5. So I put the numbers in order. It says take a sample. See, a sample of numbers taken from a big bucket of numbers. So so imagine there's a big bucket. Focus. Big bucket of numbers, and we reach in and pull out some numbers, and we list them, and then you're not going to need to put them in order. I'm going to show you how to do it on the calculator. Stay focused. Okay. But I put them in order right now just to demonstrate a few things. So we just want to describe these numbers. So normally what we say first is, well, how many numbers are there? So sample size, how many numbers are in our sample? It gets the special symbol lowercase n. And if I count these all up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, there is n equals 11. So sample size of n equal 11. Okay, now if there's 11 of them, let's see, 11 of them, so that would mean 1, 2, 3, 4, 5 of them here. The middle number, 1, 2, 3, 4, 5 of them here. So the middle number we call the median. So the median is 12. The smallest number, we'll call that the minimum. The low, minimum. And then the max, the biggest number, either the low, high, min, max. A couple different ways you can say it. The max is the biggest number, 72. And now imagine if we're just looking at the left side, what if we want the middle number on the left side? So you see how the middle number on the left side, there's 1, 2, 3, 4, 5 numbers. So the middle number on the left side would be 8. And then the middle number on the right side would be 19. Imagine, if you will, I draw a chocolate bar. If I chop it in half, right here's the median. And if I chop the left side in half, then there's 25% here and 25% here. And if I chop the right side in half, 25%, 25%. So if you break things up into 25%, you break them up into quarters. So let's call this location the first quarter. Median, I guess, is technically Q2. And then over here we have Q3, third quarter. So Q1, Q3. So the Q1 is 8. And the Q3 is 19. Okay, so these 5 things right here, that's known as our 5-number summary. My stupid webcam keeps focusing and unfocusing. We're just going to ignore that and assume everything is good. Okay, 5-number summary is the min, Q1, median, Q3, and the max. Sample size. Okay, so our little worksheet, what do they want next? Oh, so let me show you how to do this on the calculator. So now that we understand the concept, hopefully you were able to get a calculator. If not, don't freak out. We'll figure something out. But let's say you have one. So turn it on. On. Okay, now we need to give it that list of numbers. So go to stat. See how it says stat right there on that one. Stat. Edit, as in edit a list. Okay, enter. L1. My L1's nice and clean. Yours might have numbers. I'm going to slide over just to demonstrate. If I slide over to L2, if I want to clean out L2, I would slide up, hit clear, and then hit enter. And now it's nice and clean. But let's slide back to L1. So slide back to L1. I'm going to give it the numbers. You don't have to put the numbers in order. So the original numbers are 10, hit enter, 11, enter, 5, enter 7, enter 8, enter 12, enter 23, enter 18, enter 15, enter 19, enter 72, enter. Okay. And then we're going to press the stat button once again, stat, and then slide over to calc. and one of our stats, that first thing that's lit up is good. There's one variable stats. We just gave it one variable. Hit enter. And then it'll do L1 by default, but if you want to explicitly give it L1, you see how above the 1 in blue, it says L1, so you could hit the blue button and then the 1, so it says L1. But if I just hit enter, it'll automatically do L1 by default. So enter. And it spits out all this information, but kind of notice here it says N is 11. Okay, that's what we had, sample size. Slide down. Oh, min of 5, Q1 of 8, median, Q3, max. So it gives us the 5-number summary. Let's see if we got it correct. 5, 8, 12, 1972. Good. It gives us some more information that we're going to talk about more later. But you probably heard of the mean. If you take we call it the average, but technically there's many things that are averages. But if you were to add up all the numbers and divide by how many there are, that's the mean. So X bar is the sample mean, and X bar we said was equal to 18.18.18. I'm just going to call it 18.18. Let's not talk about rounding today. I'll usually tell you how to round. And when in doubt, round it like the 4th place. But right now it's just put 18.18. This is more of just making sure we understand how to work our calculators. And then S, our calculator calls it S sub X, because they're pretending that the numbers we entered, they're X's. So they're calling it the S sub X. But if we're lazy, we just call it the S, the sample standard deviation of those numbers. So the calculator calls it S sub X. We call it S, same thing. And S was equal to 18.6805. I'm just going to call it 18.68. Again, we're just rounding to the hundredths place for no particular reason. I just want to make sure you can throw your numbers in your calculator and get it to spit out these numbers. Okay, so hopefully all is going well. They want us to do a box plot now. Okay, box plot. So based on your 5-number summary, we might want to draw a pretty picture. So over here, I'm going to draw a little graph. The numbers go from like 5 to 72. So you could number by like 5s or 10s or 20s. Just do a normal number. Don't number by 17s. I'll just go by 10s. 10, 20, 30, 40, 50, 60, 70. So 10, 20, 30, 40, 50, 60, 70. Could I have made it bigger? Yeah. Would that have made more sense? Yes. Okay, we're going to draw a picture. Let me draw a couple of different box plots. They look... There's an example of a box plot where maybe it has a really long whisker. Oh, they're technically called box and whisker plots. You see how it has that general shape? There's 1, 2, 3, 4, 5 vertical lines. On the outsides are the whiskers, and in the center is the box. It's technically called a box and whisker plot, but we just call it a box plot. Okay, so there's 5 vertical lines, right? 1, 2, 3, 4, 5 vertical lines, and those are the 5-number summaries. So these numbers right here. So I'm going to put a vertical line at 5, 8, 12, 19, and 72. 5, 8, 12, 19, 72. On the outside are the whiskers, and on the inside is the box. And if I had a pencil, it would look a lot prettier. Okay, and that's our box plot. And you see how it's sort of floating above. It's not sitting on top of that axis on bottom. So a couple things. Always make sure you put the little tick marks on bottom, the interval first, because you don't want to... You want to make sure every space represents the same amount of distance. Okay, so now, so this is our box plot. We're going to improve upon that box plot by accounting for outliers. Outliers is just a fancy way of saying, hey, does one of these numbers not belong? So in statistics, people argue, is it a science or is it an art? It's a little bit of both. But if I'm looking at these numbers, it seems to me as if, let's see, which one would be outliers? I don't know if the 72 belongs. I feel like I could just remove it and just be justified. But technically speaking, there is a definition for outliers. Let me just move this over here. So organized. Okay, so our outliers are, so Q1 minus 1.5 times IQR. Anything below that, and anything above Q3 plus 1.5 times the IQR. Oh, I never asked you to define what an IQR is. Okay, so let me add that to the worksheet. It'll be right above this. So the IQR is the interquartile, can I spell? Range. IQR. So the IQR is equal to Q3 minus Q1. And the Q3 we said was 19, and the Q1 was 8, so our IQR is 11. Okay. Where are we? Okay, we're 11 minutes into the video. Amazing. So now if we bring it back up here, so outliers are below this number. So Q1, 8 minus 1.5. Oh, people really like when I put a star there or a multiply sign. They go, oh, you mean when they're sitting next to each other, that means multiply? Yeah, it does. The IQR was 11. Okay. And then plugging in the numbers here, Q3, so 19 plus 1.5, IQR of 11. Okay, so just bust out your calculator. Remember to do your order of operations first. So let's see, on, clear, 8 minus 1.5 times 11 is negative 8.5. Need a new pen. Okay, now down here, 19 plus 1.5 times 11. I'm going to pretend you can see this. I'm talking you through it. Enter 35.5. Okay, so anything below negative 8.5 is an outlier. We're going to call this the lower fence. Only books use that term. The lower fence. This is our upper fence then, obviously. Okay, so when I go back and I look at that original data set of numbers, is there any number below negative 8.5? No, there's nothing below negative 8.5. Is there anything above 35.5? Yeah, 72. So based on this sort of dictionary definition of outliers, 72 is an outlier. So when the little worksheet says, are there any outliers, say, yeah, 72 is an outlier. Why? Because it's more than the upper fence, which has a value of 35.5. Oh, yeah, that makes sense. Okay, draw a box plot. Okay, so now our box plot. So our box plot, let's see, we went by tens. Let's do the same thing. 10, 20, 30, 40, 50, 60, 70. So what we do with our box plot now is we denote outliers with a little star. So 72 is an outlier. 10, 20, 30, 40, 50, 60, 70. If I had graph paper, that'd be a lot cooler. So 72 is an outlier. So 72 gets a little star. If there was more than one outlier, there'd be a bunch of stars, right? Let's say there's also 74, then I put another little star right here. So every outlier gets its own star. Okay, now everything is kind of the same. So no vertical line. Let's ignore that for a second. On the bottom side, we said 5. I'm just going to put a dot for a second. 5, 8, 12, 19. Okay. And then sometimes, like our book, it depends on the software. So sometimes software creates box plots for you. Instead of putting a little vertical line, they just sort of have it go like that. And then now here's where it gets tricky. This whisker is going to go all the way until the last number that's not an outlier. So before 72, what was the last number not an outlier? 23. So my little whisker is going to go to 23, which is about right there. Aha! So maybe you want to put a little vertical line here since it goes all the way to the end. That's fine. You'll notice our book does not do that. But this definitely does not get a vertical line. So it stops at the last number that's not an outlier, and the outliers get stars. Okay, 15 minutes into this. We're almost done. It says, hey, draw a picture of a random box plot that is symmetric, skew left, and skew right. So symmetric is easy to draw. Let me make sure I'm filming this. Symmetric. We all know what symmetry is. So this cut this in half perfectly. And then the same thing. Yeah, symmetric. Maybe here's another symmetric one. Maybe it looks like a pretty symmetric, right? If you flip it on itself, it looks the same. Okay, so those guys are symmetric. Now imagine if you have one that looked like this. Looks like a lot of the data gets kind of spread out over here on the right side, kind of skewed over on the right side. Oh, okay, so that's easy to remember that this one is skewed to the right. And if I draw another picture like that, this one would obviously be skewed to the left. Okay, now let's see if any of this made sense to you folks. Bonus question. We'll draw a little picture here. That. So that distance, that distance. Okay, now that distance, this, that. Okay, so here's the question for you. What percentage of the data is in this right whisker? The same. Okay, so pause for a second. Maybe. What percentage of the data is in this right whisker? Ponder. Okay, I'm going to reveal the answer. Well, remember, how do we make a box and whisker plot? By using the quartile. So by definition, this is 25%, 25%, 25%, 25%. Oh, I get it.